Hello and welcome back. In this video, we are working through another example of graphing a cylinder. In the end of the last video, I mentioned the definition of what a cylinder is, any surface that is parallel to a line, and I mentioned in this class, we're just going to be looking at cylinders that are parallel to a coordinate axis. So like the last example we looked at, these ones were parallel to the z-axis, and we can also see in the equation it was missing the z variable. That is our key to recognizing a cylinder. It's an equation in 3 dimensions where only 2 of the 3 variables are present. That third variable that's left out of the equation is the same variable that represents the axis that the surface is parallel to. So that's like what we're extruding along, is that missing variable's axis. Let's look at an example. So let's consider the graph of the equation z squared plus 4y squared equals 16. We can recognize immediately that I'm talking about a graph in 3 dimensions, but only 2 of the variables are present here. We're missing x variable. So that is this surface, whatever this is going to be parallel or extruded along the x-axis. So the cylinder is going to look like it's coming towards us and away from us. And then what is it that's extruded? Well, that comes from recognizing this equation. Do you recognize this equation? I talked about these in those intro videos to this section, the basic curves in 2D. Should recognize this as one of the forms of an ellipse. And in that video where I talked about ellipses, I also mentioned how we can graph this. This isn't sort of our standard form. One thing I can do to this is divide everything by 16 so that we're equal to 1 over here. And that's our sort of standard form. So I'll have z squared over 16 plus y squared over 4, right? 4 over 16 is 4. Or rather 1/4, you get the idea, equal to 1. And now I'm going to go one step further here. Remember that in most of our equations, these guys are squared, right? This is like a squared and b squared. So I'm going to write this as 4 squared plus y squared over 2 squared equal to 1. So this is an ellipse. If I set, let's say, y equal to 0, in order to get 1 out, I need z to be either 4 or -4. That'll give me 1 out. So when y is equal to 0, z is equal to 4 or -4. When z is equal to 0, y is equal to 2 or -2. So I'm going to try and remember that. I'm going to set up my axes here, x, y, z. And I'm just going to draw it now. So instead of drawing in the xy plane, which I did for the previous one because we were missing the z variable, I'm going to draw in the yz plane because we're missing the x variable. So I'm going to draw it like, well, here's my yz plane. I'm going to draw it in that plane. And we have an ellipse. So like I said, when y is equal to 0, so that would be when we're on the z axis, I have intercepts of 4 and -4. So let's see, 1, 2, 3, 4, 1, 2, 3, 4. So my curve in the yz plane will intersect those 2 points. And then let's see, when z is equal to 0, so that's the y-axis, I get positive or -2. So I know my ellipse in the yz plane intersects these 2 points. Notice I'm really just working in the yz plane here, and now I'm going to connect these in an elliptical fashion. Whoops, let's try that again. Come on, drawing tool, there we go. Again, doesn't have to be perfect, I'm not an artist, but the idea is there. This is an ellipse. Okay, so that's the yz trace of this figure. I want to also notice, right, setting x equal to anything. So if I push this forward or push it back, I'm going to end up with the same ellipse. So one thing I'll do here is I'm going to draw those other traces. So I'm going to make parallel lines to the x-axis. I'm going to do dotted lines because these are not part of the surface and also not blue. I'll make those parallel lines. Parallel to the x-axis. I'm going to do ones up here too. These are also parallel to the x-axis. That's the top line and the bottom line. Top and bottom bounds of my figure. Just want to be able to draw this as accurately as I can with these sort of fumbly fingers. Some of you are going to be much better drawers than I am, and that's totally cool. So let's see. Let's maybe draw this one. Remember, this is my top line, so I can draw a point here. I'm going to draw it along here. How do I keep this? How do I keep these distances matched up? I want to be careful about this. One way I can keep this looking right and without too much work is I notice the z and the y-axis, right? These are perpendicular to each other. So if I move down from this top point of the ellipse out here at this trace, I can move down to the axis, to the x-axis. That would be where the y-axis, not the y-axis, but a line parallel to the y-axis would be at this x value, and then I will travel outward from that. So it would be right here. That would be this point, but now closer to us. And let's see, I can do the same thing over here. That would be this one. Right, that's the same point. And then finally, this last downward one, that's going to be right parallel, a line through this down here. So there is now an ellipse at this positive x value. So this would be, I don't know, setting x equal to, I don't know, 5. I don't have any x values marked here, and it really doesn't matter for our purposes here. And then I'll do the same thing over here. So let's see, let me maybe pick this for my top value. Travel down and over 2. Travel down over 2. Travel down to this one. Here's another ellipse. I'm going to be a little bit careful with this because some of this ellipse I'm not going to be able to see. All right, so this is going to kind of be on the back side of the ellipse. I'm not really going to be able to see that if this is a surface. I didn't do that for these ones. I wouldn't be able to see those as well. Hopefully you're sort of getting the idea there. And then I'm going to connect these traces. So now I have 3 traces drawn. Now I'm going to connect these with parallel lines just to give this some dimension to it. Because again, this is not a collection of curves, but rather a surface. So drawing these parallel lines to the x-axis are going to help us. I already sort of have them drawn, don't I? How about that? These are going to help us see this as a surface. So it looks like, I don't know, like maybe you would have thought it would be a cylinder. This is an ellipse though, right? This isn't a perfect circle here, so this is what we would call an elliptic cylinder. The previous example we did where they were parabolic traces, parabolas, this was a parabolic cylinder, and this one is a elliptical cylinder. Or elliptic, I'll say elliptical cylinder. Pretty cool. Let me jump to, I think I have something in our textbook for this, or rather the textbook author has it in there. There is, so this isn't quite the one we just looked at. So this would be so imagine what would the equation of this one look like. So my xy trace is an ellipse. So this is missing the z coordinate. So this will look something like, I don't know, it looks like maybe 4x squared plus 2y squared equal to 16, something like that would be about right. And we'd be missing the z coordinate. So this is similar, not quite what we had, what we just drew. That's okay. We want to be able to, right, sort of change things, right, change the variables around and be able to recognize it. Right, and these interactive figures are kind of cool because it walks you through the drawing process, right? So sketch the curve in the xy plane. That was because there was no z value in the equation of this one. Draw a second trace, and then draw a parallel line. I did 3 traces just because it helps me draw it a little bit, and then you draw your parallel lines. And then you can draw lighter outer edges sort of around that if you want to give it a little bit more definition. And what we have there is an elliptic cylinder. This one, again, isn't just the one that we just drew. Ours was in the YZ plane and then extruded along the x-axis. This one is the XY plane extruded along the z-axis. Ours was missing the x variable. This one would be missing the z variable. Okay. That is it for this video. That's it for talking about cylinders. There's another couple examples that you can work through. All sorts of cylinders you can make. Again, the key here is that they are parallel to a line. in these cases, axes. All right. See you next time. We'll talk about quadric surfaces. See you there.